But today, we're starting with Samya, Ayish from the Google News Initiative and Anatoliy, Bondarenko from the Ukrainian data journalism agency Texty. And we're going to have this session to explain and showcase how journalists can use machine learning to enhance their reporting. We are very proud of this session because we've been working very hard as a team and in collaboration with these wonderful people to create training resources that might help journalists understand the power of machine learning. Earlier this year, we published an introduction to machine learning on the training center of our sponsor, the Google News Initiative, which really introduced the potential of machine learning for journalists and help you reflect on how you can use it responsibly in your own reporting. But today, we are super excited to announce that we have a follow-up course that Anatoliy and myself have been working on for weeks this fall, which is a hands-on version. So it's a machine learning again, but it complements the introduction of the first course to really guide you through a very practical exercise about how you can use you can train a machine learning model to identify and classify images in vast data sets. So we're really excited to check it online. The link, I believe, is being shared by the team on both YouTube and Telegram. And we are really excited to launch this today, and we're looking forward to your feedback as you take it. This is where my presentation ends. So I bring myself back on screen, and I bring back on screen also our fantastic speaker, Samya and Anatoliy. Thanks for being here with us. As I was saying, we're really excited to have you, and we're going to do this session in a very dynamic way. So both of you will have your moment to shine very soon. Anatoliy, I'm going to come to you first, and I know you are going to share some of your work. It's been a pleasure, of course, for us to be collaborating with you and your team on creating the training course. And we're really excited about all the investigative projects that you're doing. And you're really a great example of how journalists might use machine learning. So we want to hear from you and give you the opportunity to tell us a bit more about the work that your team is doing at Texty. So the floor is yours.
Okay, thank you. My name is Anatoliy, and I'm a head of data journalism at Texty, small independent Ukrainian media. And technically speaking, we used AI or machine learning. In many of our projects for the last 3 years, but it could be arranged in 3 parts. It's statistical Bayesian modeling, it's a classical machine learning, and it's deep neural models. But my main point of all of this is that machine learning or AI is a big force multiplier. With recent advances in deep neural networks and classical machine learning, you could do projects which were just impossible in the past. And here is a couple of our projects, of our examples. And first of them is our analysis. Unfortunately, it's only in Ukrainian, but I will describe it in short. This project it's about analysis of our parliament for 2014-2019 years, and there were more than 10,000 of bills voted during this period. And first, what we done, first we converted those votes for each member of parliament into some kind of mathematical object called a vector, basically a set of numbers. And for example, it could be done when we each vote yes, we represent it as 1, or each vote nay as 0, for example. It's just example. And when you have a vectors, you could do many interesting operations on them. You could group it or cluster. You could compare differences, and also we in such way we grouped, clusterized in some space all function of parliament, each MP. Also, we created some kind of fictional ideal member of parliament who voted for most progressive, most pro-reform bills, and we calculated distance from this ideal member of parliament to different factions in our parliament, and this is temporal dynamic of this difference. So the more a chart is, the more ideal the voting was. So and this chart has a very good correlation with real political events for those time, for example. Also, we found in such a way we found most divided topics, and also we found some kind of temporal evolution of different factions of parliament with this method. So you could see how some kind of coalition was made, how it broke, and so on. So this is kind of, as I say, it's kind of temporal dynamics of each of faction in our parliament for those years. Okay, that was my first example, and second example is a project called Topic Radar, and we made this project to look to study and to look dynamics of Russian disinformation topics in Ukrainian informational sphere, so to say. And we collect each week we collect tens of thousands of news items, mainly in Russian, from about 400 sources, and we select only relevant news about politics, economy, society, and external affairs in Ukraine, with one of our deep neural models for natural language processing. After that, our second deep neural language model select only manipulative news from all those news items. And this particular model trained on a data set with news items manually labeled by news professionals, journalists and editors. After that, we did topic modeling to cluster news items by topics. And the result of this clustering with a sample of news items for each topics you could see on this news application. And so you could see dynamics, big main meta topics, and if you dive in, you could find some examples and temporal dynamics of such topics. By the way, it's very okay, and this project, of course, would be absolutely impossible without automatic classifiers based on our deep neural language models, based on AI. And by the way, this project is a winner of Sigma Awards for this years. If you don't know, the Sigma Awards is kind of a reincarnation of now defunct Data Journalism Awards. So this project is a winner in category of news application, best news application. Okay, and our my third example is, of course, Leprosy of the Land, and to create first interactive map of with a trace of illegal amber mining. This map we trained custom built image classifier, also based on neural models, and with the help of this classifier, we found all places of illegal amber mining in the northwest part of Ukraine. And without such a model, it would be impossible for us to search half of million satellite images manually. And it's a big pleasure for me that new course from JournalismAI is based on this case. So Again, for us, is AI or machine learning is a new understanding of what is possible and a big force multiplier. We just it will be possible for us to make any of these projects without help of AI. So, okay, that's all I wanted to say. And thank you for possibility to speak on this festival.
Thanks to you, Anatoly. It's been fantastic to follow your work, and thanks for sharing some of those examples. All links to these stories will be shared in our summaries and takeaways. But to everyone that is listening us from home, you can already head to texty.org.ua, and you will be able to see and explore for yourself most of the stories that Anatoly has been mentioning, is much more. And of course, as he was saying, as you take our new training course, which again, the link has been already shared on our channels, both on YouTube and if you're following us on Telegram. And you will be able to use Leprosy of the Land as the case study that you go through to learn how to train a machine learning model in a simplified way, of course, but in the same way that the Anatoly's team did at Texty for that fantastic investigation in 2018. And I must say, well done on my former team at the AJC to recognizing the quality of your work in the Sigma Awards. So congratulations to the team, Anatoly. Good. So really excited for this introduction. And again, I strongly recommend you to check out the training course if you are interested in that. The links will be pretty much everywhere, so you're not going to be able to miss it, even if you want to. And now it's my pleasure to give the floor to Samya, who will tell us a bit more about various training initiatives that her team at the Google News Initiative is running based on machine learning. And Samya is the News Lab leader in the MENA region, if I am correct. And I am very, very happy to have Samya here with us today to tell us a bit more. So for the rest 20 to 30 minutes, the floor is entirely hers. So Samya, thanks so much for being with us.
Thank you very much, Mattia, for the introduction, and thanks for the JournalismAI Festival. Sorry for the great first edition. I am personally enjoying every bit and piece of this wonderful festival, and most importantly, learning so much from the experts and the different collaborations happening between the different newsrooms. I'm also happy today to be part of this panel along with Anatoliy from Texty and the one and only Mattia. So let me start by opening my presentation, and in which we will be, of course, talking about machine learning. And today, actually, we will be taking you through the training courses available on the Google News Initiative Training Center, as well as teaching you how to train a machine learning model to identify and classify images. So my name is Samya Ayish. I'm the Google News Lab Teaching Fellow in the Middle East and North Africa. And of course, that means I train journalists who speak Arabic in this part of the world. And today we're going to be actually doing a number of things. But first, let's start with some fun. I would like to introduce to you the first tool for the day, which is Google Quick Draw. This is actually an AI experiment developed by Google. And I think now we are going to be sharing the link with you so that everyone can just open the link and you can start experimenting with your drawing skills. But here is how it works. So if I go to Let's Draw, the system or the website is going to give me some words that I can start drawing in 20 seconds. So a lantern, let's say how good I am at drawing a lantern, if I'm gonna, and so on. Let's see if that's gonna work. I don't think I'm that good at drawing a lantern, or maybe, I don't know, it's not the right way of drawing a lantern, but it's not gonna get it. So let's move on to the next one. So for the spoon now, let's draw a spoon. Now I'm good at drawing a spoon. Let's move into a pizza. It's a circle. So again, it's a pizza, and our fourth drawing is a remote control. I think let's go ahead and it's a remote control. Okay, and our fifth drawing for the day is drums. So I think I would know how to draw drums. So that was fast. And the last one is a lobster. Okay, that's a hard one. So let's try, and it's a lobster. Okay, so as you can see, we have finished 6 drawings in total. And if you go to any of these drawings, let's go to the pizza, for example, it's going to give you some matches. So it's going to give me a correct match. It's going to give me the closest match. It's going to give me a third closest match. And then if I move down, it's going to show me all the previous attempts by people who came to this website and they started drawing the different words that appear in front of them. So if I go back, of course, just to let you know that you can also share your drawings. So it would be nice if you can share the drawings that you just did on social media, on Twitter and on Facebook, using the festival's hashtag, which is JournalismAI, to show the world that we're not just brilliant journalists, but also brilliant artists. Okay, so let's just talk a little bit about how this works. So the system here, or the model here, asks people to join this game, which is fun. But actually, what it does, it's actually trying to collect as many data as possible to include in what we have as the world's largest doodling data set. And this is something that I really love seeing here. So this data set shows, as you can see, a lot of items from around the world, items that we use, items that we have in our homes, and so on. And for each one of these items, we have a lot of drawings and sketches. So if I go to the apple, for example, you can see that there are 139,898 apple drawings made by real people. And that's how the model is learning. So we have the sketches getting into the model, and then the model is becoming better at making these guesses. So as you can see, you can keep on scrolling to see all the different sketches that are available for the model to learn from. So let me go back to my presentation and continue talking about what we have for the day. So moving on from drawing to a resource that we always love to show, which is the A to Z of AI, which I'm going to be opening here. So this is simply a guide. It's a beginner's guide, and it's a collaboration between the Oxford Internet Institute and Google. In this guide, which is a beginner's guide, as I said, it tries to teach people as much as possible about AI, but in a very simplistic way. So I highly recommend that you also go to this website, which is also available in different languages, and start learning bits and pieces about artificial intelligence and machine learning. Okay, and now let's move on to talk a little bit about the courses that Mattia introduced at the beginning of the session today. So the first one, which we have up on the website since April this year, focuses on the conceptual side of AI and machine learning in newsrooms. So as you can see, it talks about the difference between machine learning and AI. It talks about the different approaches to machine learning, how we can use machine learning. It talks about bias and so on. It also talks about how machine learning and AI are becoming integrated in our newsrooms, sometimes without even us realizing that. So this is a very interesting course for those who are starting with machine learning, and it's definitely important for all of you to at least learn more about the conceptual side of these ideas. Now, this week, we have launched the second course, which is more hands-on. And today, of course, I will be taking you through the main concept of this course, which is, as I have said earlier, focuses on teaching you how to train a machine learning model. So in this course, you have the data sets, you have the tool, you have the different steps, which include preparing the data, uploading the data, evaluating, testing, and so on. So as you can see, we have talked about machine learning and we have talked about the courses and everything, but every time we talk about machine learning, we talk about data. which means that we need a data. So for today, of course, thanks to our friends in Texty who have built a machine learning model, as mentioned by Anatoliy a while ago, to help identify illegal mines in the Ukraine using satellite imagery. So today we are going to be using these labeled images from Texty to teach you the fundamentals of how you can build and train such a model. So I talk a lot about, the data and the data set and the images from Texty and so on. So just to give you a little sample of what we're talking about, these data sets are divided into two labeled image sets. The first one is the negative image set. As you can see, it's the top row here, which has about 900 images. And these are the negative, of course. And the other set is the positive, which is the second row in here. And it has about 250 images. Now, in a perfect scenario, the tool tells you that you should have at least 10 images, but it's highly recommended that you use at least 100 images in order for the model to learn better. And of course, the more images you have, the better it is for the model to learn better and better. So today we're gonna take you through the process of how to create the model on the Google Cloud platform. So in order not to confuse you, I have decided to break that process down into a number of steps so that we know where we are at each step. So the first step that we're going to be doing is that we're going to go to the Google Cloud platform and we're going to be creating our account and our project, and then we're going to be importing the data set. After that, we will start training the data set, and then we will evaluate it, and finally we will go ahead and test the data set and deploy it. So the first thing that we need to do is obviously head to the tool, which is the console, which is, as I said, the tool that or the platform that we're going to be using in order to build our model for the day. And in specific, inside the Google Cloud platform, we are going to use the Google Cloud Vision API. So let's go ahead and click on the console right away here. When we are inside the console, just one thing before I talk about what we're going to be doing in here, be aware that in order to start using this platform, you need to enter your credit card details. Not because we're going to be charging you, because we won't be charging you, but it's because we just want to make sure that you are not a robot. You are a real human being trying to test and experiment with artificial intelligence. Unfortunately, there is no other way around that. So that's the only way that you can actually start using this platform. But the good news, and here's the good news, once you have signed up and you started creating your first project, you will get $300 free cloud credits to experiment with. So we have created our account, and we are now on the first page of our Google Cloud platform. The first thing that we are going to be doing is creating a project. So you have to go here and just click on New Project to create the project, and you can have as many projects as you want inside your account. So I went ahead and I created my first project, which is the MENA machine learning test. The second thing is that we have to go to the Vision tab because we are dealing with images. We are creating a model that should be able to classify and read images. So we're going to go to the left navigation bar, the navigation bar on the left, and then we're going to go down until we find the Vision tab. So on the Vision tab, where we are right now, this is where we are going to go to the data set. So the data set is where we will be uploading all our images. But remember that we are talking about images. So our data set is made up of images, and one important task to do before uploading these images is tagging them. So I have to get each image and I have to say, this is a positive, this is a negative, this is a negative, this is a positive, and so on. So as you can imagine, this is a very consuming task, and it takes a lot of time. So thanks to Texty today, we're not going to do that because they have already tagged all the images for us as either positive or negative. So this means that all what we have to do now is just upload the data set or upload the images and start building the model. So when we go to new data set, so we have to upload our images through the new data set here. So let's call it, for example, I'm just going to create one for now. Let's call it AI, and you have to use underscores in the data set name. So AI fest underscore ML, let's call it test2, for example. And then we make sure that we click on the single label classification and we create the data set. Now, the data set is going to be created. So once the data set is created, this is what we will have in front of us. And this is where we will be able to import all our images on the inside the data set. So as you can see, the different file types for the images that are supported include JPEG, PNG, GIF, bitmap, ICO, and zip. So in this case, what I'm going to do is that I'm going to be uploading two labeled images, zip files. The first is the positive images, and the other is the negative. The positive labels and the negatives label. So I'm going to select the files, and then I'm going to go to browse because I have to put them inside a bucket. So that's my bucket for the day, and then I will hit continue. Of course, uploading the images will take a little bit of time. So we're not going to do that right now because I have already did that before. And I'm going to head directly to my this set, which I have already created before. And I have uploaded all the images on it. So let's imagine that we just created our first data set and we have uploaded the images, and the images are already uploaded. And here is what we have. As you can see, these are all the images that were inside the two different sets, the negatives and the positives. The total is 1,150 images. 900 of them are negative, and 250 of them are positive. So after we uploaded the images, it's time now that we start training our model. So all we have to do is just go to train, which is right here, and then we will get this message. This message says that we have enough images to start training. Obviously, there are like more than 1,000 images. So it means that everything is working well, and the model is ready to be to start training. I just want to shed light on a very important aspect, which is not all the photos, or sorry, not all the images would be used for the training. Part of it would be used for the training. So for example, the negative labels, 720 of them would be used for the training. And then the rest is left for validation. So we have 90 for validation, and then we have another 90 for the testing. And the same goes for the positive. So all what we have to do is start training, and training usually takes about 8 hours. So you can specify it as 8 hours for computation, but I can tell you that it would take less than that. So you don't have to worry about that many that length of time for evaluating for training your data set or your model. But of course, again, since this is this will take much time, it's not going to take 8 hours, but of course, it's not going to take 8 minutes. So what I did is that I already trained my model before. So I think it is this one, which I have already trained. So as you can see, you have the images uploaded, and then if I go to train, it says that it finished training, and this is the summary of what are the results of the training. So as you can see, it gave me an average precision of 0.99. This means that it's the model has worked well. And there are two important things that we have to pay attention in here. The first one is the precision, and the precision is how many times the model has made mistakes within this data set. So if it's very high, it means that so the higher the number, the fewer the false positives the model has got. And then the other one is the recall. And the recall refers to the higher the number of the recalls, the fewer the false negatives the model has got. So it made less mistakes. So the first one, it made more predictions, more right predictions. And for the second one, it made less mistakes. Now, the nice thing about this tool is that it will allow me to also look at the evaluation in a more specific manner. So if I go to see full evaluation here, or I can simply go to evaluate right away from here, as you can see, it's going to show me the same information that I just saw. But one important aspect added here is the confidence threshold. So the confidence threshold refers to the level of confidence the model has on this given data set. And by the way, you can play around with this threshold. So for example, if you move it up to let's say 0.91, you can see that the precision and the recall percentages are gonna be different. So at 0.5 or let's put it at 0.5, for example, it was about 95 to 96% for both of them. But once we increase it to 0.8, for example, while we're gonna have more precision, the number of recalls is going to be less, which means that we have a higher percentage or a higher number of false negatives inside our model. Also on the side, you can also experiment with the graph by trying different points along the different graphs and to see how the precision and the recall percentages are changing whenever we change the confidence threshold. But at the end of the day, this is the optimal confidence threshold that was offered by the model. The other thing is the confusion matrix. So the confusion matrix shows you in simple words, for example, how many negatives were labeled as negatives, how many negatives were labeled as positive, and vice versa. How many positives were labeled as negatives and how many positives were labeled as positive. Now, the main takeaway from this particular table is the diagonal boxes. So if you look at the blue boxes that are diagonally aligned, these boxes should include the highest percentages to show that your model is working well and it's ready to be tested and deployed. If we have bigger numbers or larger numbers in other boxes other than the blue boxes, this means that we have to revisit our model, we have to revisit our data sets, and we have to keep on improving on that. So the main takeaway is that the diagonal blue boxes should have the highest numbers. So after we do the evaluation and we are good with everything that has been offered and given by the model, all we have to do now is to go ahead and start testing and deploying the model. Now, make sure that if you are experimenting and testing, if you hit deploy, try to hit undeploy later, because it will start charging. And once you get charged, it's actually kind of expensive. So just to make sure that you don't waste your credits on, just experimenting and testing with this particular model. So once you do that, your model will be ready, and you'll be able to have it read even bigger data sets, and it will be trained to do that already. Personally, these are all information that, coming from a journalism background, I didn't know before. But after trying and, learning about all these things from the courses offered on the GNI, it was actually interesting and exciting, because I didn't know anything about, artificial intelligence or machine learning or data sets and data science and so on. But trying something like that makes me very proud. And after you go through the different courses, you should be also very proud of yourself creating your first model. So the last thing that I want to talk about, and I think I have a few minutes left, is a number of case studies that we have seen across different media platforms. I think they're being shared with you now on the chat spaces on Telegram and YouTube. So these are different case studies that have actually used machine learning and artificial intelligence in their story coverage and in their data collection in order to look at huge data and information that has to do with the topics of these different stories. So just to wrap up, I encourage you to go and visit the 2 courses on the Google News Initiative website training center, the Introduction to Machine Learning and the Hands-on Machine Learning. Go through them, try to take the lessons, try to build your first model. And by the way, all the data sets that are provided by Texty for the day, thanks to them, are already available on the second training course, which is the hands-on machine learning. So you can use those data sets in order to experiment and build your first machine learning. And please don't forget to tell us on social media how that works for you. Of course, this is provided in addition to a number of many other courses that are available on the Google News Initiative website. And we always remind you that we support newsrooms. So if you have any questions regarding any trainings or tools, don't hesitate to contact us on the NewsLab support at google.com email. We deliver our trainings on Google Meet these days. So I think I have reached the end of my presentation. So thank you very much. And I would hand it back now to Mattia to see if we have any questions or if there is any comment or anything to continue this conversation. Thank you very much.
Thank you so much, Samya, for this wonderful presentation. I'm going to bring back Anatoliy with us as well, so we can all share the screen together. Anatoliy, I think Samya did just an excellent job at guiding people through our course. So I'm proud. Very good.
Very brilliant job.
Thank you.
Samya, for this. As you could tell from Samya's presentation, the training course is it's really hands-on. It's not just about the title. So you will really be able to test things for yourself, being guided through the indications that Anatoliy and I prepared over the past few weeks. So please do go to the training center of the Google News Initiative. Remember to take the Introduction to Machine Learning first, if you haven't done it already, because it's very useful and propedeutic to them being able to understand everything that is explained in the second one. So we have plenty of time for Q&As, and there are questions that started already coming in on our channels. So I love how our community is not shy at all to go nerdy and technical about this. So the first question is actually for you, Anatoliy, as people were really curious to know more about your work at Texty. And I will bring in the question on screen if I can right now, because Thomas was commenting. Of course, this is beautiful work, explaining what you were doing. But Thomas is also asking if you can tell us a bit more about how you generate your document vector representations in the Twitter analysis. And he was also saying, for example, do you use contextualized embeddings for something like BERT, or does it work in a different way? Anything you can tell us a little bit? Don't be shy and afraid of being too nerdy. We would love to know more from you.
Okay, I just don't get it. Don't follow it. What is this question about? So I not mentioned any kind of Twitter analysis in my talk. So it's probably some kind of misunderstanding. But if our reader, our listener, probably it's about representation of news items, of news topics, of news items from our analysis of topics of Russian disinformation. So if in this case, I could answer that our natural language processing model is based on ULM fit model from Fast AI course. I think most of our listeners, of participants, heard about Fast AI course and about brilliant work of Jeremy Howard and it's another. So our language model is based on ULM fit. And we used to transfer learning. We trained it on Russian and Ukrainian Wikipedia corpus text and transferred it to and fine-tuned it on corpus of news items from Russian and Ukrainian media source. So I don't know, is it the correct answer, but because okay.
I think it is. So yes, Thomas is actually saying on the comments right now that that's exactly what he meant. So thank you for the explanation. It's been appreciated. Samya, I'll come back to you because I was very interested in what you explained also during this course, how yourself, not having any background in machine learning, these courses were some of the first, one of the first ways that you got to understand how you could use it in your own work. So I was wondering if you could tell us a bit more about that, and maybe specifically, was there any point in the courses, in the two courses that we have created, that you think is particularly useful for journalists that want to understand what machine learning can do for them?
Sure. Now, there's always this fear of the big concepts. Like, you know, when you say artificial intelligence, like everybody is like, wow, but there is like fear, you know, like this is something that maybe we don't understand because we all come from journalism backgrounds. Maybe it has to do with the ones and zeros and you know, like very technical terms and, you know, data and so on. So there's always that fear, but you know, like once, because these courses provide or offer this information in a very simplified, in a step-by-step way, I think that fear is kind of removed. So that barrier is no longer there. Now, as I mentioned, I never had that experience before, but although, you know, the only thing that I was just doing is uploading tag data and hitting, you know, like train and upload and continue and I don't know what, but that still made me very proud of myself because I think that's the beginning. So once you start familiarizing yourself with the wordings, with the concepts, with the definition of these different approaches, I think that's where the solution starts. We've all been through many different things that were new to us in terms of like video production, social media. But now when we remember those days, I mean, we learned everything about them. So I think the same thing has to do with artificial intelligence. And I think these courses are just the beginning of a very bright future on that.
Thank you so much, Samya. Maybe I should put a disclaimer. I didn't pay Samya to say all these nice things about our training courses, but of course, we appreciate that. So thank you. And we do hope that everyone has this experience as taking the training courses themselves. I think, as Samya was mentioning, these are very much an introduction, so a starting point for journalists to familiarize themselves. But within the courses, we actually recommend at the end further resources that you can use to just find out even more about what machine learning can do for you. Anatoliy was actually mentioning Fast AI, and they have a huge repository of courses and recommendations to follow for journalists. As well, I want to mention the unfortunately now defunct Quartz AI studio, who did a fantastic job across 2019 of building training resources for journalists to understand exactly these topics. So you can still check out qz.ai and find loads of useful materials that really complement very well our own courses. So there's no competition in there. Anatoliy, I wanted to come back to you. We didn't prep this, so sorry if I am improvising on this part, but I was wondering if you could tell us a bit more about your team at Texty and how you actually started using machine learning to the point that it has become so integral to everything you do.
Okay, just a little follow-up for my previous questions. We actually published very detailed methodology in our GitHub. So you could go to our GitHub and to see which algorithms, which models we used for our main projects with AI or with ML. So it's with examples of code. Okay, so currently we are, as you know, we are a very small newsroom. It's about probably 15 people at all, and our data team consists of 7 people, and which is relatively big amount, to say the truth. And the part connected to ML, machine learning or AI, the part of work, only 3 people do this part of connected, do the project connected to machine learning. So it's about probably 3 people, 3 or 4 people, and I think it's probably because of some specific technical background from part of our members. We started back in time. We started to learn about after classical statistical analysis or data analysis. We started to pay attention to machine learning, and in recent 2 or 3 years to deep neural models, and we found, as I said today, that we can make a project with such a scale that was impossible without this method. So we started to invest heavily in this. I mean, in terms of time, in terms of courses, of different courses, and online and offline, and so it began. So to say, so something like this.
Yeah, thank you so much. I mean, it's quite impressive, I think, in such a short amount of time, just talking about a few years, like the level of like implementation and use cases that now you can create with machine learning. So well done to that. Samya, of course, unfortunately, not all newsrooms are like Texty. It's not easy for many to start understanding the value of these tools and actually how to use them as well. So I was wondering if in your experience as in the region, as you were talking to newsrooms, what do they tell you about these topics? What are their concerns beyond those that we discussed already, maybe about just this sounding so grand and big and complicated?
Now, I think because there is not much of a deep understanding of this particular topic, and because there are other requirements inside newsrooms by journalists. So, for example, sometimes I go to newsrooms that do not have fast internet, or they are just, like we have electricity cutting off every hour. So how can you ask those, small newsrooms or even big newsrooms sometimes to how can you talk to them about artificial intelligence? I really love the conversations that are taking place in the Journalism AI Festival, because, as I said at the beginning, it's also about understanding this topic like more closely. So, as I said, artificial intelligence might be something scary. Like a lot of people think that it might cost a lot of money even. But I think there was like a session yesterday where, it was said that, you start with the minor things, you start with the very little details that might not be a priority for the newsrooms. You start to engage journalists in the conversation about artificial intelligence and machine learning. And I think that's what some newsrooms, at least in this part of the world, are doing, because from journalists, I can see that there is so much need and so much, hunger to learning more about the technologies. But on the other hand, of course, there's reality that, they have to face and they have to live with. But again, going back to your point, your first question, at least this course gives us the, the luxury of learning until circumstances are better, where we can improve things in reality.
Thank you, Samya. That's a great point, and it definitely matches, of course, some of our own experience at the JournalismAI project and what we have learned by talking with newsrooms throughout these 2 years. I was saying throughout the years because it sounds such a long time, but it's actually not even 2 years that this project has been up and running. And I just wanted to remark, I mean, as in this call, we're speaking from London, Dubai, and Kiev. I think this is really the example of how global this network is. And I'm really proud also that the entire lineup of the festival is able to show how machine learning experiments are coming literally from across the world. We already had in the first 2 days sessions from Peru to Hong Kong, and now this wonderful global lineup. So that's, I think it's really important to keep reminding ourselves how there are cultural differences and technical differences. I think it was really striking to hear Samya about, in some countries, maybe just most basic issues about Wi-Fi or electricity connection might be a huge limitation to the use of these technologies. And we need to keep that into account as we try to explain the value of this all. But really, I hope that this network is clearly showing how we can also learn from one another, that it's not just about waiting for the New York Timeses and the Financial Timeses of the world to show us the way, but teams like Anatoliy's at Texty are doing a fantastic job at really showing us what's possible. So I think we are close to wrapping up the conversation. So Anatoliy, I just wanted to come back to you for one final question, which is, can you give us a sense of preview of anything exciting your team is working on, and or what would you wish to do in the future as these technologies continue to develop?
We after we got some experience with natural language processing, now the entire world around us, because we started to use it's like a kind of a drug. You started to use it more and more. So, and in one of our future projects, we used natural language processing to analyze actually how DMCA requests are used to politically censoring journalistic materials here in Ukraine. But I guess it's not only in our case, but it's very interesting because we with the help of NLP, with the help of neural models, we could analyze and cluster together some kind of different types of attacks, different group of which type of articles some bad actors try to delete, for example, from search results in Google with a false DMCA request. So I guess it's very interesting topic, and I hope that will be interesting thing to read after we created it. So but actually, really we use in each second our project now we use natural language processing. So it's a huge thing for us.
Perfect. So I'm looking forward to have you back at the second edition of the festival, maybe 1 year from now, and hear more about the new projects you have been developing in the meanwhile. That's exciting, and we're looking forward to read and continue to follow the work of your team. Of course, there's a lot of interesting work that the team at Texty has been doing already, and we will make sure to keep sharing links to case studies and presentations from their work throughout our channels. So for those listening us on the other side of the screen, keep checking the Telegram group, which you can access at t.me/journalismai. And just to keep engaging with us, send us any questions through any kind of channels, Twitter with the hashtag JournalismAI, as Samya mentioned before. And of course, if you're here, probably you are receiving our newsletter, so keep an eye in your inbox for all the additional links that will give you more context and information about the projects that everybody is running in this fantastic network. I think I can stop my blubbering here and get this session to a close. A big thanks to Samya and Anatoliy for joining us today. I am excited that I've been able to present with you our new training course, which I encourage everybody to take online on the training center of the Google News Initiative. And with this, I close, and I'll see you all back online at 2 p.m. GMT this afternoon to hear about BBC News Labs and their own experiments with AI. Thank you, everybody.
Thank you.
Thank you.